What's up, guys? My name is Michael and welcome to my YouTube channel. So today we're going to talk about advanced functions. So we're going to learn about overloaded member functions, overloading operators, which is really weird, but you'll understand why, and then how to write functions to support classes with dynamic allocated variables. So let's start with overloaded member functions. Basically, overloaded member functions are just basically the same thing as overloading functions. So remember, I told you about overloading. Overloading just means same name, but different parameters. So you could have overloaded member functions. As you can see here, look at this. Here, they overload this draw shape method. So the first one is a const, right? But that takes no parameters. And the second one takes a width and a height. So that's how you overload your method functions. To overload method functions, you just change your parameters. That's all you have to do. They have to have different parameters, same name, different parameters. So what they did was here in draw shape, they actually, in this overloaded draw shape, they actually called the second draw shape, which is in the passing in its width and its height. And in here, in the its width and its height, they just print out stuff. That's all I did. So I'm going to basically, I'm not going to type this up because all they did was they just, in draw shape, they just, draw shape taking no parameters. All they did was they just passed in its width and its height, which is the instance variables right here, because each rectangle has a width and a height. So all they did was they passed this into the second function. They called the second function with its width and its height. See? And then in the second function, all they did was just draw the shape in a for loop and print out every single star and from I to the height, and then every single star, and then they print out a new line. That's all they did. So that draws out a rectangle. So that's basically how you do overloaded method functions. Just change the variable, change the parameters. Change the parameters. There's also something called default values. So we talked about default values before. Just as global functions can have one or more default values, member functions of a class can also have default values. So it's the same way as we did before. You just have a default value in your declaration first, and then in your definition, you just do whatever it is. So yeah, they had a constructor like this with the default value, and they said if the default value is true, then they set the print width to its width and its height. And then otherwise they set print width to the parameter values. That's basically all they did. So choosing between default values and overloaded functions, the columns are the same thing, but the overloaded functions in 10.1 are easier to understand and more natural to use. Also, if a third variation is needed, perhaps the user wants to supply either the width or the height, but not both. It is easy to extend the overloaded functions. The default value, however, will quickly become unusable complex as new variations are added. So how do you determine if you want to overload or use a default value? Here's a rule of thumb. All you do is just for overloading functions, there's no reason default value needs to exist. You might need different algorithms, and you need to support different types in your parameter list. So the default constructor. The point of a constructor is to establish an object, just like before we talked about how objects are created, or the constructor establishes the object by passing in the values to easily initialize each instance variable, right? So before the constructor runs, no rectangle exists, only an area of memory. After the constructor finishes, there's a complete ready-to-use rectangle object. This is a key benefit of object-oriented programming. A calling function does not have to ensure that the object starts in a self-consistent state. So if you do not explicitly declare a constructor for your class, remember the default constructor created takes no parameters and does nothing, and you are free to create your own default constructor. However, that takes no arguments, but that sets up your object as required. The constructor provided for you is the default constructor, but by convention is any constructor with no parameters. But this might be confusing. The default constructor is basically just a constructor without any parameters. That's what it is. So if you don't provide one, if you don't write your own default constructor, they automatically give one to you, and it doesn't do anything. It doesn't really do anything, but it is usually clear from the context. So you can also overload constructors. Constructors, just like member functions, can be overloaded. The capability to overload constructors is very powerful and very flexible. So for example, if you want a rectangle object to have two constructors, the first takes the length and width, and the second makes the rectangle of the size. The second takes no values and makes the default. To implement it, you just do this. Just change the type of parameters. Make sure that they have different parameters. That's how you overload constructors. So here, all they did was the default values for the default constructor, they just set the instance variables of its width to 5 and its length to 10. Then in the constructor in the rectangle, the second constructor, the overloaded one, they had different parameters, width and length, and this time you define your own width and length when you create the rectangle. It's not created for 5 and 10, so then they set its width to width and then its length to length. So these things are the two different default constructors. Finally, the one is just as it may be any overloaded function, the compiler chooses the right constructor. So initializing objects. So up to now, you've basically all we did is setting the member variables of objects in the body of the constructor. Constructors, however, are invoked in two stages: initialization stage and the body. So most variables are either set in either stage by initializing it in the initialization stage or by assigning it in the body of the constructor. It is cleaner, however, and more efficient to initialize member variables at the initialization stage. So the following shows how you could do it. So if you want to initialize the variables, like set its age to 5 and its weight to 8 in the default constructor, right? You could easily just do, instead of doing like its age equal to 5, its weight equal to 8, you could do it in an initialization list. So all you have to do is just put a colon and then do its age and then put 5 and its weight equal to 8. Its weight not equal, its weight parentheses 8. Pass these 5 and 8 into this, and this would just initialize its age and its weight. And these two are just instance variables. Its int age and its weight of the cat. So after you put the closing parentheses on the constructor's parameter list, write a colon and then write the name of the member variable and a pair of parentheses. Inside the parentheses, write the expression to be used to initialize the member variable. If more than one initialization exists, separate each with a comma. So that's all you have to do. And to do that, they did it like this. This is the initialization block. Initialization of member variables. So all they do is they had the name of the instance variables and then a parentheses and then what value they want, and then the name of the instance variables, parentheses, and then what value they want. So that's easier to do and it's faster. After this colon is added the default values. So in this overloaded function, 2 parameters are passed and then I'm actually going to explain the code to you. So I'm going to copy down this whole code and then explain to you how the rectangle works. So I copied up the code. So basically all it is just a rectangle class that has a rectangle constructor and then a rectangle constructor where you pass in the width and the length to initialize your rectangle, then a destructor, and then they have the get width and get length, and these just return the values of the width and the length, and then they have private instance variables called its width and its length. So in their default constructor, they just initialize the variables to 5 and 10, and then in their the overloaded constructor, they basically just have 2 variables of width and length, and they pass in width and length. So then in main, all they did was create a rectangle, and they print out the width and length of rectangle 1, because to call your default constructor, you just don't pass in any parentheses, not parentheses, you don't pass in any values. So this would just have a default value of 5 and 10. Then they ask you, okay, enter a width, and then you enter a width and length, and then then they create a rectangle for you, rectangle 2, and then you pass in the width and length you want to create based on what you enter from the keyboard, and then they print out the width and length from there. So here, I'll just run it for you guys. I should have put a system pause. Okay, so look at this. Rectangle 1 width is 5, and then rectangle 1 length is 10, and it's because that here they created a rectangle 1, right? And this called the default constructor because you didn't put in parentheses to initialize your rectangle for its instance variables. That's why it called the default constructor. It automatically calls the default constructor. So then that's why in the default constructor, they just initialize width and length to 5 and 10. So that's why when you print it out, when you get its width and length, it's 5 and 10. Now if I put like width 100 and then length 10, it prints out width 100 and length 10. Here, I'll just do a system pause. See, okay, so width is 5 and then length is 10. So if I do 100 and then I do 10, it actually initializes the width and length to 110. So now, about the initialization block, there's a faster way to do it, and all you have to do is you put a colon and then you initialize your variables after the class's name in the implementation. So right here, you see rectangle, right? Rectangle, colon, colon, and rectangle. What you do is you put a separate colon, and then you do its width. This is the name of the instance variable that you want to initialize. You should put 5 and then comma, do its length, and 10. And then that should, and then you don't need this here, and this is faster. So over here, just do a colon, then do its width, and then pass in the width, comma, its length, and then pass in the length. And what this does is it's basically saying, okay, I'm going to initialize your instance variables its width to have the first parameter of width, and then its length to have the second parameter of length. So here in this is the second constructor, which this was the overloaded constructor. And what this overloaded constructor did was it initialized your instance variables based on whatever you passed in for the width and the length. So right here, remember they passed in the width and the length. Here, you passed in width and length here because they wanted to initialize your rectangle 2 with the values from the keyboard that you input from the keyboard. So then it initializes rectangle 2 with here, this, and this. So this time, instead of doing its width equal to width, we put it in an initialization block. So then this should have the same effect. For here, enter width, I put 100 and I put 10, and it actually has the same effect. So you actually put when you're initializing your instance variables, just put them in this initialization block. All right, the copy constructor. So remember, whenever we passed in objects by value in last video, it invokes the copy constructor. So when you pass an object by value, it either goes into the function and it invokes a copy constructor because a temporary copy of that object is made. Whenever you pass variables into functions, they create a completely temporary separate copy. So that's why it always did the copy constructor. It always invoked the copy constructor, and we talked about why this is not good and that's why we should pass it by reference. So if an object is user defined, the class's copy constructor is called, and you saw this yesterday. But all copy constructors take one parameter. So basically, it's a reference to an object of the same class, and it is a good idea to make it a constant reference because the constructor will not have to alter the object passed in. So for example here, so you could actually write your own copy constructor, and then when you pass the object in by a value, it actually invokes the copy constructor, and then because you wrote your own copy constructor, it actually calls that copy constructor, and that's good because now it calls that copy constructor that you do and not the one that's automatically given to you. Okay, so basically copy constructors have this syntax where it's the it has the name of the object, and it takes in it's a constructor that the copy constructor takes in one parameter, and it's a reference to the object of the same class. So for example here, cat const cat, a reference to the cat. It's an object of the same class, and it's good to make it constant because the constructor will never alter this copy of the object. The constructor basically will just set its own values to have the same values as the cat. So here the cat takes a constant reference to the cat object. The goal of this copy constructor is make the exact same copy of the cat, except you want a different copy. So you want two separate copies, exact copy of whatever stuff was in the cat. So that's why we made it constant, because we're never going to change the stuff in the cat. We're just going to create a new cat, and it's going to have some of the exact same values of the cat. So the default copy constructor simply copies each member variable from the object passed in as a parameter to the member variables of the new object. This is actually called a member-wise copy or a shallow copy. So what it does is it basically takes in whatever value this thing had and the instance variables of the cat, right? And then takes in the it sets your instance variables to have the same value as the instance variables of the cat. Okay, so that's how the default copy constructor works. Although this is fine for most member variables, it breaks pretty quickly for member variables that are pointers to objects on the free store. So a shallow or member-wise copy copies exact values of one object's member variables into another objects. However, this is bad for pointers, because in the end you would have pointers in both objects end up pointing to the same memory address. So when a deep copy copies, you don't want so when you have pointers pointing to the same memory address, that's bad. But what you want is a deep copy. A deep copy copies the values allocated on the heap to newly allocated memory. So if the class cat includes a member variable, its age, that is a pointer to an integer on the free store, the default copy constructor copies the passed in cat's its age member variable to the new age cat's its age member variable. So then the two objects now point to the same memory. So that was a shallow copy. The two objects pointing to the same memory. And this is what happens. Because because its age is a pointer, right? And the default, and you create a new copy. You create a new copy of a cat, right? The default copy constructor is a shallow copy, so it just sets every single member variable, every single instance variable to equal to the exact same copy of whatever was passed in. So right now, let's say you created a cat object, right here. Let's say you created a cat object, right? And you create two cats. Basically, what it would do is the default constructor would just pass in the instance a reference to the cat, right? And then it sets whatever your current object to whatever copy it was of the cat. So have the exact same copy, like to have the exact same values in your member variables, to have the same values as the cat. So for instance, if you have the old cat, right, and you want a copy of an old cat, the copy constructor would take in that old cat as a parameter, a const parameter or whatever parameter. It would take in the old cat, right, and then it would set its age to point to the exact same value of old cat. But now, because its age is a pointer, this is bad. This is bad because it's a pointer, they both point to the same memory address. So this leads to a disaster is when cat goes out of scope. So if the original cat destructor frees this memory, so if old cat got its destructor called, the new cat is pointing to a memory address that has been freed, and this leads the program into danger. So basically, when this old cat gets destroyed from the destructor, as we see after method function calls, this memory address is gone, right? But then its age still points to it. So what we want to do is a deep copy, which is we want to create a completely separate cat and have its values be new values of 5. So here I'll just draw this out in order to make sure you guys understand. So let's say I created a cat object, right? This is old cat, right? So in my program, here I'm just gonna write, this is the code section, right? So in your code, let's say you did cat, old cat, right? You created an old cat, right? And let's say you passed in 5, right? To initialize your thing. Now, old cat takes in 5, right? And it's like, okay, it initializes the pointer of its age. So this is its age. It's a pointer, and then it allocates memory, points it to an integer variable of 5, right? So now the default, and then let's say you want to create an exact copy of cat, old cat. So then what you would do is, here in your code, let's say you created a code, cat, let's say new cat, right? You're like, oh, okay, and then I just pass in this cat, this old cat, right? And it should create a completely new copy of it, completely new copy, right? But the default copy constructor doesn't do this, right? You know that, like, if you don't write your own copy constructor, this calls the default copy constructor. So what this does is it goes like, hey, okay, I'm gonna create a complete new cat. And I'm like, okay, now its age is going to have the exact same values of its age right here. And what is its age? Its age is, what's the old its age, right? This one points to an integer variable of int 5. So it's like, okay, I'm going to copy exact same values of the memory address of here, the memory address of here. So then this points to that. So what's problem is that if this gets destroyed or freed, so this is gone, right? And then this memory's gone also. Because after the function call, we know that, like in any function call, let's say this was in main, your old cat gets freed from the destructor, right? So this is freed, but then its age still points to this. So this we don't know where this is, this memory address. So this could be anything. This could be garbage or anything. It could be anything, garbage or anything. So that's a problem. Because, and then if you try to access its age, you could have a disaster right now, because you're accessing memory that was freed. You're accessing memory that was freed from the heap. So what we want to do is we don't want to do this. So I'm going to go here, delete this. Basically, we want to create a completely separate separate object. So let's say we have cat, right? Old cat. And we have a pointer, which is an instance variable of its age. What we want to do is, so this is the old cat points to an int variable of 5, right? This is an integer. We want to do is we create two completely new cat. So then the new cat takes in the value of its age, and what it should do is it should allocate memory for this exact new one. Instead of pointing to here, it should create its own memory address, get its own memory, and be like, okay, this has 5, then it sets a value of 5. So how do you create a deep copy instead of a shallow copy? Well, here's how you do it. So I'm going to copy this code, and then I'll show you guys how it works. So I rewrote their code, and I'm going to explain what their code does. They basically have the default constructor, right here, where they created a completely new allocated memory of its age and its weight, and they allocate memory of a new integer pointer, because its age and its weight, instead of being integer variables, these are pointers. So they create a new memory for its age and its weight. Then they set that the data that it's pointing to, they set its fair value to equal to 5, and its age, its weight equal to 9. That's what they did for the default constructor. Then they created a copy constructor, and this time, instead of actually doing what the normal thing does, they allocate its age to a new, this is the new thing about it, it allocates its age to a completely new memory, and then its weight to new memory, like what we showed into the picture. This time it points to new memory, and then it said its age is equal to the original thing of RHS.getAge, which was here, whatever its age of here. They use an accessor to get whatever RHS's age, and then they set its age to have the exact value of RHS's age. Then they said its weight, the data that it's pointing to, the pointer, to have the weight, get its weight. So they did RHS.get its weight, and they did this time, instead of using get weight, instead of calling get weight, they just did dot its weight dot RHS's dot its weight. They set the pointer, and then they set the data that is pointing. They get the data of the pointer. Oh my god. They took RHS's thing. RHS is the cat, right? They took RHS's cat, then they say, okay, give me its pointer. So you do dot and then its weight. So that gave its weight's pointer, right? And then they did the star, and then that basically just says that I set its weight equal to the data that it's pointing to. Okay, that's what they did. They said star its weight is equal to star its weight. So then this basically, this accessed a RHS dot its weight. This basically accessed the pointer of what you're trying to copy, right? The pointer, and then they got the data of that pointer. RHS's dot weight. What is the weight? It's this. This is the pointer, the inch pointer, right? So they got the the weight that they were trying, the pointer that they want to copy, right? And then they dereferenced it, so now they have the data that it's pointing to. Then because we created its weight, a new pointer, right? Then we dereferenced the new pointer, right? So then we set the data that our weight is pointing to, and they set it equal to this, to their weight. So this is the right way. This is a deep copy, because you're allocating new memory. You're not just simply doing, okay, its weight is its age equals to RHS's dot age. You're not doing its age. It's okay. Let me explain this better. So we want to copy RHS's, their members variables, right? We want to have the exact same copy of the cat of RHS, because this is the thing that we're trying to copy. We want their value. We want their value, right? The exact same, every single instance variables, every single value of their instance variables, we want to have the exact same value, right? But we don't want it to point to it. We don't want to use the default, because they're pointers after the destructor. Because if you're pointing to the same one after the destructor, you can't access the memory anymore. Because if you have two objects and they're pointing to the same one, you can't access it anymore. So what we did was, our age, this is its age, right? Technically, it's the one we allocate memory for our instance variable. So this is our instance variables, right? We allocate memory for them. We allocate memory for them by making them point to new memory onto the heap, right? Then we dereference it. We set the data that our thing is pointing to now is equal to RHS's age, right? Then we're doing the data of our weight, right? Which is technically, it's called its weight in here, but the data of our weight, we set it equal to their weight, right? The data that their weight is pointing to. Because their weight is basically also a pointer, right? So then this basically says, okay, now we have separate its age and its weight, then that it's pointing to. So here I'll explain into another diagram. So here we had cat, right? Cat, and then there's RHS, right? So RHS has an age and then a weight. RHS has an age and a weight, right? And these are pointer values. So they point to whatever value. So let's say whatever. Okay, whatever value this is. Whatever, right? Now, we want the exact same copy of this, right? But we don't want to just create our cat, right, to have our age point to the exact same, point to this, to theirs. Because that's what a shallow copy does. That's what their original thing does. We don't want to do this because it's not good. So what we did was, instead of doing a shallow copy, we're going to create a deep copy. So what we did was, okay, so our age, this time we're going to allocate new memory. Because with the new keyword, it's age, right? We create our pointer, we create a new memory, right? Then we have to have a weight, right? And then we create a new memory for the weight. Then we said, okay, the data that our age is pointing to is going to have the exact same value of what their age is pointing to, RHS's. So what is that? Well, whatever value this is, let's say this was okay, let's just arbitrarily say this was 5 and this was 9, right? So whatever value this is, their age is 5, so we're going to set our value to 5. That's what this does. It gets their age and sets our value to have age, right? And then we say our weight is going to have the data that our weight is pointing to. It's going to have the data that their weight is pointing to. So the data their weight is pointing to is 9, RHS's variable. And they did that by using RHS dot their weight. So then this is a deep copy, because now we have separate copies, We're not just directly pointing our age to have the exact value of age. We created a new, completely new memory. We created a new memory, and then we set it equal to that. So that's the good thing about it. Then in our destructor, what we did was we delete its age. We free this memory. So let's say we wanted to free. This is the new cat, right? So in our destructor, after everything's called, right, the destructor, it frees the age. It frees whatever this age is, and then they set this to null. This is now null. Then they delete the weight. They free the weight. Then they set this to null also. 0 is null. See? 0, its weight is null. So that's basically it. So here and then basically here they demonstrate this by creating a cat object called Frisky, and all they did was they set the age to 6, and they passed in boots. So in their example, I'll just explain it again, and this time in their example instead of the one that we created. So what they did was they created a Frisky object, which is a cat, and they used its constructor, right? So they had an age and a weight. So what does that constructor do? So I'm at this line, right? So that constructor does is it allocates new memory for age and width right here, and it sets the values to 5 and 9 respectively. So this pointed to this is integer, this is also integer, and it sets the value to 5 and it sets the value to 9. Right now in here, then they're like, okay, we're gonna call the method setAge, and setAge is basically just sets whatever age is to whatever parameter is, and in this case they're setting age to 6. So now frisky.setAge, this becomes 6. So now age is 6 and weight is 9. Right now they're like, okay, now we're gonna create an object of boots. This is a completely new object of boots. We're gonna call this boots. We're gonna have age and then weight. So this time they passed in Frisky to the copy constructor to create this boots object. So because they passed Frisky into that copy constructor, they basically allocated new memory because they wrote their own copy constructor. Okay, so they passed in Frisky into boots, right? And they passed in Frisky into the copy constructor of the cat object and created the object boots. So what does that do? It goes here and it's like, okay, now I'm gonna create values, allocate memory for age and weight. So I did allocate memory for age and weight. I'm gonna set our age to have exact value of age 6. So that's 6, and then the weight is gonna have the exact value of weight. So then that's 6 and 9. Because we rewrote our own copy constructor, we didn't actually use the default. Default copy constructor would have just set these values to that. Would have done that. And that's not what we want. So we allocate new memory, and then we dereference it so that we have the exact same values of the copy constructor, right? Not the exact same values of Frisky. So now when we print age, the Frisky's age is going to be 6. And now when we print Boots' age, it's going to also be 6. So now when we set Frisky's age to 7, if we set Frisky's age to 7, Frisky's age is going to be 7 and Boots' age is going to be 6. So let's see what happens. So look, that's what happened. Originally, Frisky's age is 5, what we said. Then we set then we set Frisky to 6, right? Set Frisky to 6. So now age is 5, and then weight is age is 6, and then weight is 9, right? Then when we create Boots from Frisky, we passed in 6 and 9. Passing 6 and 9 for passing 6 and 9 for the copy constructor into Boots. So now from Frisky to Boots, it's going to have values 6 and 9. So Frisky's age is 6, Boots' age is 6. Now when we set Frisky to 7, because we create our own copy constructor, Frisky's age is going to have the value 7, and Boots' age is going to have the value 6. Now if we didn't include this copy constructor, look what happens. So let's say I comment out this. They're going to point to the same memory address. And what would happen is that they're both going to have values of 6. Oh, no, 7, my bad, 7. Because you set Frisky to 7, and I'll show you why. Now, if we didn't rewrite our copy constructor, this is going to make a shallow copy. So what is a shallow copy? Shallow copy is easy. It's not good for pointers, but if it was anything other than pointers, it's fine. Because for pointers, if after your destructor, it frees the memory, whatever memory it was, and then that causes problems. But for regular values, it has no problem. So what happened was we created Frisky, right? This is a shallow copy. This is a shallow. Let's call it shallow. So in a shallow copy, Frisky's age is age. So originally, Frisky's age points to 5, and weight points to 9. Because we called it in the constructor, the default constructor, which we wrote, which initializes it to age to 5 and weight to 9, right? So then what happens is now, after we did that, we set Frisky's age to 6. Okay, so then this becomes 6. Because we called it the set age function. That set it to 6. Now we're like, okay, now we're going to create a copy of Boots. Create a new copy, we call this Boots, and it's going to have the exact same values of Frisky. Because we didn't rewrite the copy constructor to have a deep copy, this is a shallow copy. So now age points to the exact value of age, and then weight points to their weight. See? And the reason why it does this is because it goes member by member. It says, okay, age points. What is the memory address of age? Age is a pointer, right? It holds a memory address. Okay, we're going to have it the exact same value of that memory address. So that's why they point it to the same value. So then when we do get age and get Boots got get age, it's going to be 6 and 6 right here. 6 and 6. Frisky's age is 6. Boots' age is 6. Then when we set Frisky's age to 7. Frisky's age is 7. Boots' age also gets changed to 7. And that's bad. It's bad for pointers. Because then when one of the values gets freed, when it calls the destructor after this method call, it's bad because then this gets freed. This whole memory gets freed. And then our Boots, when we try to access our age for Boots, the age and weight of Boots, then it's nothing. It's gone. You can't access garbage. That's why. So that's why shallow copies are bad. For pointers, that is. For regular methods, for regular integer values, it doesn't matter. Because age would just have the value 7 or 9. Alright, so I'm going to press any key to continue. Whoops. I did something stupid. Okay, so that's what happened. Okay, and it was freed twice. Did you see that error that I got? Because it was freed twice. Because this got freed, right? This 6 got freed, right? Frisky's, because it calls it destructor Frisky, right? And then after it prints out the age of Boots, it tries to free the age of, it calls the destructor of Boots, right? And the destructor Boots frees its age and its weight. So then that you're freeing twice. We're freeing memory that's garbage. This is garbage. So when we free this, it causes an exception to form. That's why. So that was the whole thing about copy constructors and destructors. So for deep copy, you actually create a separate value, and I showed you about that. Alright guys, now let's talk about operator overloading. Basically, remember C++ has built-in types of int, float, char, and so forth, and each of these types have addition, multiplication, subtraction, division. Well, you could actually rewrite these fully. You could rewrite what subtraction does, you could rewrite what division does, you could rewrite whatever multiplication does. Now, should you do it? No, you shouldn't, but sometimes it's good to do it. Alright, so in this case, let's say let's create a counter class. So I'm going to clap, and then I'm going to magically type this up, and then I'll explain what it does to you. Alright guys, so in this case, I just typed up what counter does. Basically, counter has a constructor and a destructor, and then it has a function called getItsValue, which returns the value of the counter, and then they have a set value of passing in x, and then they set the value of the counter to x, and then they increment counter. No, they have a function called increment that increments a pre-increment of the value of counter, and then the value of counter is just as another instance variable. It's an instance variable that is private. So basically, all they did was in the default constructor, they initialized its value to 0 using this, basically, and then they did nothing in the default constructor because they just initialized value to 0. And for a main, they created a counter with counter called an object counter, and it's called I, right? And then because they did it this way, they called the default constructor. So they called this because they didn't pass in anything to I, right? So then it just set the value to 0. So now then they printed out the value of I, then they incremented the value of I, then they printed out the value of I again. So let's just see what that does. So what that does is that just sets I to 0 and then I to 1. It prints out the value of 0, then it has the value I equal to 1. That's what it does. Because they printed out the value of I, originally it's 0, then they incremented I, and then they should have the value 1 after it. So now let's talk about overloading this. Now, although this works, it is cumbersome to use. You having an increment function every time to increment a value is cumbersome to use, right? So the easier way to do is to have overload the plus plus operator. So we're going to rewrite what plus plus does. It's overloading the plus plus operator. To overload the plus plus operator, you do this. You do put void, the return type of what you want your function to do. Then you type operator. Then you say whatever the plus plus it is, whatever operator it is you want to overload. So if I want to rewrite what plus plus does, I do void operator plus plus. If I want to rewrite what division does, I do void operator divide, and then the parentheses, and then whatever you want to do. So this statement indicates that you're overloading the plus plus operator, and it will not result in a return value. Thus, the void is the return type. So we just rewrote what plus plus does. This time it does not return a value. So originally when we did increment, normally when you do I plus plus, or a plus plus I, let's say more specifically, it actually just adds the value of I by 1 and then returns it, right? So now this time we're not returning anything for increment. All right, we're rewriting what plus plus does, and we're setting the return type to be void. Okay, so now instead we're going to overload the operator, and I'm going to copy this code, and then I'll just tell you what it does. Alright guys, so let's just see what this code did. Basically, all we did was we rewrote what the operator plus plus does. So now, instead of returning something like what plus plus does for an integer, right? It adds 1, then it returns the integer value. This time we don't do that. We do plus plus its value, and we don't return anything. So now, in this case, when the value of I is, right? We print out the value of I. Originally it's 0, right? Because we initialized it to 0 in the default constructor. So we initialize the value to 0, right? Then we increment I. We call the increment method. And then now it increments the method to have 1, right? But we don't want to write an increment method. Instead, what we did was now we did the value of I is, right? We print the value of I is 1. Now we did plus plus I. So now we changed what the value plus plus does. Now instead of adding 1 to only for integer values, for integer values or for doubles or characters or floats, we added 1 to our counter object. Counter I was added 1. So now we do plus plus I, the counter. It called the overloaded operator plus plus method of counter, and then it added plus plus its value. That's what it did. Okay, so now when we print out the value of I again, it's gonna have the value 2, because we added 1 here, and it added brand value, then we added again 1 to have 2. So that's a good thing about operator overloading, is that now you can use plus plus, minus minus, divide, multiply on objects. You could do that on objects. So since this thing was overloaded, that overloaded value simply increments the value of the private. This overloaded is then used is so much simpler to the syntax instead of just using it for an int. Right? At this point, you might consider putting extra capabilities for which counter was created in the first place, such as detecting when counter overruns its maximum size. A significant defect exists in the way the counter object was written. However, if you put the counter on the right side of an assignment, it will fail. Okay? It will fail. So if I did counter A is equal to plus plus I. So right now we know the counter I, right? Counter I, the object counter of I, has a value of 2, right? Now this time I want to create a new counter A. Now I'm going to do plus plus I. This won't work. Okay, you know why this won't work? This code intends to create a new counter A and then assign it to the value in I after I is incremented. The built-in copy constructor will handle this assignment, right? So the built-in copy constructor will handle, like if you do counter A is equal to counter B, right? It would handle this assignment, but the current increment operator does not return the counter object. It returns void. So this doesn't work because our current increment operator that we created returns void. You can't assign a void to anything, including a counter object. So you can't make something from nothing. So returning types in overloaded operator function. Clearly what we want to do is return a counter object. So if you wanted to have it assigned to another counter object, which object should be returned, the easy way to do is to create a temporary object and return that. So to do that, in our counter operator plus plus, what we're going to do is we're basically going to increment its value, then create a temporary object, set its value to have its value, then return it. So I'm going to write that right now. So here in our counter operator right here, we're going to do counter operator. So here we're going to do counter void. No, whoops. It's counter operator. Then we're going to do this. I'm going to cut this out. So it just has this declaration. Alright, and then we're going to do counter is going to be counter. Like that, I think. Wait, no, it's like that. It's that. Counter. Wait, let me look at the syntax again. Yeah, counter. And then do that. So what this does is this is going to return. It's going to return a operator, a counter object. So this is the counter object that's going to return. So originally it was like void, right? And it just added 1. This time we're going to return a counter. So what we're going to do is we're going to create a temporary counter object. Then we're going to temp.set its value to have its value. Then we're going to return temp. So now we could use the operator. Now what's the problem? Okay, the problem here is that what is actually the problem here? Counter. It's not void. Let me see. What is the raw oh, I forgot the parentheses. Oh, no, I didn't. I put the parentheses. Counter. Oh, let me see. Counter. Oh, count. It's supposed to return counter. Yeah. I forgot to change this to counter. So now we could actually do plus plus on our counter object and set it equal to another thing, because it returns a counter. So now when I did counter A equals to that plus plus I, A now has a called the copy constructor and passed in the plus plus I of the value of plus plus I into A in the copy constructor. So okay, so I was a counter object, right? Then I incremented I and I incremented again. So I'm using the plus plus operator because I overloaded the plus plus operator, right? So then I was 0, 1, right? Now then 0, 1 because I did increment, right? And 2. So now I'm going to counter A is equal to this plus plus again. So this is going to be 3. So counter A is going to have the exact value, the values of 3. Counter A is going to have 3. Okay. Then this is good because now we could use plus plus on objects. We could use multiplication on objects. We could use division on objects. We could use modulus on objects, whatever you want, because now it could return things. Now what it can do is now it can modify, because we've rewritten the what plus plus does on integers. Now we could do that on objects and many other things. So what is this going to return? Yeah, I'm going to print out the value of A and then print out the value of I. Okay. So I'm going to print out the value of A and then print out the value of I. So now when I print out the value of A and the value of I, they're both going to have A is equal to 3 and I equals to 3 because we did plus plus and then we set the counter A to have the values of I. That's what we did. Okay, the counter object. It's a counter object, by the way. So why do I keep clicking that? This has been declared, and then the temporary temp is created, and then the value is set to match the current object as being incremented. When the increment is complete, the temporary variable is returned, and that allowed us to use the assignment. And that temporary variable that is returned is now assigned A. So now returning nameless temporaries. There's no need to name the temporary object created on line 29. If counter had a constructor that took a value, you could simply return the result of that constructor as a return value of the increment operator. Ooh, so now let's illustrate this idea. So instead of doing the thing, this time it just returns the just called the constructor of its value and then returned it. So it called the constructor and it just returned the thing. So if we created a constructor, initialize it to have whatever its value is, then we could just easily just call it and then return it. So that easily works, and it takes out the need of creating the temporary object. So instead of doing this now, we're going to comment this out. No, just delete it. So now we're going to return something. We want to return, and this time we're going to call we're going to return an object. We're going to create a constructor that allows us to initialize the value. So then now we could just return this. I have to do the counter of int x. So we have to do. Now here we have to do counter what is going on? Type name is not allowed. What? But I created let's see what's the problem. Oh, wait. Okay, my fault. So normally you would do this, create a temporary, then return temp. This would work, but then instead of doing that, we're just not going to create a temp and just call the constructor of counter and return that. It's easy. We don't have to create a temporary object. We just call the constructor of temp of counter. So then this initializes its value to whatever value it is. In this case is x. So then it initializes its value to x, which is its value. So then now counter, the operator plus plus is going to add 1. We don't have to create a temporary object. So that's what we did. Using this pointer. So this pointer is passed to all of the member functions, including the overloaded operators such as plus plus. In the listing you've created, this points to I, and if it is dereferenced, it returns the object I, which already has the right value in its member variable, its variables. This illustrates the dereference of this pointer to avoid the creation of unneeded temporary objects. So what they did was, in here, you don't even need to create a new object. In fact, you could just return this. Return the data at this, that this is pointing to. So here, instead of doing this, we're just going to return star this. Because this is pointing to, this just has one value, which is its value, right? So now we can just do that. And then we don't even need the we don't even need the copy constructor of this. Not a copy constructor, the constructor that initializes this value. So now we don't need this. We don't need this. And then you could even set this to constant. You could set this operator to constant. Oh wait, whoops. You actually have to set the you have to set this also to constant. So if you do const counter, oh, you could even make this a reference. It's not going to change anything. So now here we do const counter and return this, so then it doesn't change anything, because it doesn't change the object you're pointing to. That's what it doesn't. It returns a reference. That's what it does. Has the implementation of plus has been changed to dereference to this pointer to return the current object. This provides a counter object to be assigned to A as discussed. If the counter object allocated memory, it would be important to override the copy constructor. In this case, the default copy constructor works fine. Note that the value returned is a counter reference, thereby avoiding the creation of an extra temporary object. It is a const reference because the value should not be changed by the function using the return counter. The return counter object must be constant. If it wasn't, then it would be possible to perform operations on that return object that might change its values. For example, if the thing was not constant, then you would have to do counter A. You could do counter A plus 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 I. What you should expect from this is that increment operator would be called on the result of plus plus I. This would actually result in calling the increment operator on the object I twice. So this would do I, which is something you should most likely block. So try changing the return value to non-constant in both the declaration and as shown in line 3, do plus 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 and put a breakpoint in the debugger to see and step in to see what happens to the plus plus operator. So I'm not gonna do that, but you guys could try. What change it to not constant and do plus 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 I and see what happens. Anyway, overload the postfix operator. So far you overloaded the prefix operator. What if you wanted to overload the postfix operator? Here the compiler has a problem. How do you tell the difference between prefix and postfix? Integer variable is supplied to a parameter in the operator declaration. The parameter's value is ignored. It is just signaled as a postfix operator. So the difference between prefix and postfix is that it's fetch and increment. So thus, although the prefix operator can simply increment the value and then return the object itself, the postfix must return the value that existed before it was incremented. To do this, you must create a temporary object that holds the original value, increment the object of that original value, then return the temporary object. So to go over that, if A is equal to X plus plus, A then equals to X, then X gets added 1. So X for 5, this A is equal to 5, then X is equal to 6. So thus the value in X is returned and assigned to A, and the value of X is increased. If X is an object, its postfix increment operator must be stashed away from the original value in a temporary object and increment that and return the temporary object to A. So there's actually no way to tell the difference between prefix and postfix. You have to code that in yourself. So to do that, just have a flag, operator the flag or whatever it is that tells you if it's prefix or postfix. So if to do that, we could easily do Creating object. Okay. So do that. You do what they do. They did const operator plus plus for postfix. So we're gonna rewrite. We're gonna add that here. It's gonna be postfix now. Now we're gonna go here and then we're gonna rewrite the postfix. So to do that, to rewrite the postfix, all we did was have a flag to tell the difference between the prefix and the postfix. Then what we do is we create a temporary object that has the exact, call the constructor of the temporary object, passing the data of the current object that you're in, add increment its value, then return it. So then a now equals to, if a is equal to 5, and you did the thing, it's going to return the current value, then add 1, and then return the temporary. So to do that, to call it though, we'd use this. We have the flag that tells the difference between it's a postfix. So now when we run it, it has a value 3 and I equals to 4. So to tell the difference of a postfix, you create a flag. Instead, you now have the flag int, and that tells the thing that it's a postfix. That's what it does. Okay. Prefix is declared there. The parameter passed in the postfix operator serves to signal that it is a postfix operator, but this value is never used. So yeah, you could actually tell the difference between a prefix and the postfix by simply just passing in the flag, and that tells it's a postfix. So overloading binary operators, you could overload multiplication, division, subtraction. Consider how you would overload plus for count. The goal is to declare 2. If you're going to overload subtraction, multiplication, division, and modulus, this helps you if you want to add 2 objects together. So if your goal is to create 2 counter variables and then add them, you could do that. You could create 3 variables and you could now add them, because now you rewrote the plus operator to work on objects as well for your counter or whatever object you're doing. So now, once again, you could do all this just by creating a separate function for add, subtract, multiply, and divide, but it's actually better to do this way. This would take count as an argument, add its values, and then return count with the result. So that's what they did here. They overloaded the plus. No, they didn't even do that. They just rewrote an add instead of overloading the plus operator. But yeah, you could do that. You could just create your own add function. I'm not gonna do that. Overloading the plus operator. So yeah, you could. This time we could rewrite what the plus does. If you want your 2 objects to add together, you could rewrite what the plus does also. And in this case, what they did was they did that. Okay. Okay, so there's issues in operator overloading. Operator overloading can be member functions as described in the thing, and in the special class functions. When you learn about friend functions, the only operators that must be class members are the assignment, subscript, function call, and indirection operators. So the only operators that must be class members are the assignment, subscript, function call, and indirectional operators. Operator bracket is discussed on day 13 as managing arrays and strings. When arrays are covered, the operator thing is discussed in day 5 when smart pointers are discussed. So the overloaded operators can be member functions. So yeah, that's the thing. Limitations in operator overloading. Operators for built-in types such as and cannot be overloaded. The precedence order cannot be changed, and the arity of the operator, that is, whether it's binary or unary, cannot be changed. So you cannot make up new operators. So you cannot declare star to be the power of the operator of. Arity refers to how many terms are used in the operator. So some C++ operators are unary, and some are just one term, plus. Some operators are binary and use 2 terms. So only one operator is ternary and use 3 terms. The ternary operator is often called a ternary because it uses 3 terms. So what to overload operators? Operator overloading is one of the aspects in C++ most overused and abused by new programmers. It is tempting to create a new interesting uses for some more obscure operators, but these lead to code inability and difficulty to read. Of course, the plus operator, subtract operator, switching, making plus operator subtract and multiply operator to become add is fun, but no professional programmer would do that. The danger lies in the well-intentioned but idiosyncratic use of an operator, using plus to mean concatenate a series of letters or divide to split a string. This is good reason to consider these uses, but there is much better way to proceed with caution. Remember, the goal of operator overloading is to increase usability and understandability. So to use operator overloading to overloading to clarify the program, use objects from the overloaded operators. Assignment operator. The fourth and final function that can be supplied by the compiler if you don't specify is the assignment operator. So you could also overload the assignment. The assignment operator is called whenever you assign an object. For example, you create a cat1 and cat2 to have the age and a weight 5, 7, and a 3, 4, and you assign cat2 to equal to cat1. You could overload the equal sign. Here, cat1 is created initialized with 5 and 7, 3, 4. After a while, 2 is assigned to the values in cat1. Two issues are here. What happens if it's a pointer? So this equals is a shallow copy. It copies the values of cat1 have 3, 4, right? Then it does cat2 now has the values of 3, 4, and 3, 4. This is okay because the age and weight are just integer variables. They're primitives, right? But what if they're pointers? If they're pointers, that's different, because then they're pointing to the same memory address, integer variables. They have the same integer pointers. So then in the destructor, when you free it, problem occurs because you're freeing twice. After the destructor of 1 and 2, you're freed twice because they're pointing to the same memory address. We talked about that. This is a shallow copy. All right, so that's why we want to create a deep copy. What happens if it's a pointer? Now then you're handling this problem. So to differentiate a copy, shallow copy just copies the members. Both end up pointing to the same area on the memory. Deep copy allocates the necessary memory. So easier way to do this is to overload the equal sign. So how would you do that? Well, you would overload the equal sign. You do this. So I'm going to clap and then copy this code and then see where it... So this time I overloaded the equals sign. So now instead of doing a shallow copy, I'm going to do a deep copy. So to do this, if we want to avoid having them point to the same memory address, all you have to do is just do dereference your pointers and then set it equal to the cat object that you're passing in, and then dot their instance variables of theirs. So set yours, dereference your pointer to equal to their accessors of their age and their weight. So that prevents a shallow copy, because then now your pointers are not pointing to the same memory addresses as theirs. You changed your data of your pointers to have the values of theirs. So the difference between this is that they're not pointing to the same memory address. They're pointing to different ones. Okay, its age, because you already allocated memory for its age, right? You're just setting your data to equal to their data. Now, and then after that, you return the star this. So you return the memory address of your not memory address. Your object. You're returning the data at your object. That's what you're doing. Returning because you're returning a reference of the thing. Now the reason why we do if this is equal to RHS is because that what if you assign cat2 to itself? Like if you did cat2 to cat equal to cat2. No one is likely doing this on purpose. It is however possible for this to happen by accident when reference and dereference pointers hide the fact that the assignment is to itself. So if you did not handle this carefully, cat2 would actually delete its memory allocation, and then when it tries to copy the values from the memory on the right side of the assignment, that would be a huge problem. The value would be gone because it deletes its own memory allocation, because it would call the destructor and it sets the values of that thing. So to protect this, your assignment operator must check to see if the right-hand side of the assignment operator is the object itself. It does this by examining the value of this pointer. So this pointer then shows a class with a assignment operator overloading. It also does the thing that we mentioned. So what we do is now we have this pointer. We return star this. And the reason why we do return star this is that this is a pointer. Every time in C++, this is a pointer to the current object, right? So when we do star this, it's the data that this is pointing to, which is the object. So here, I'll just draw why we do star this, just to understand, tell you guys what star this means. So basically, in all your functions, you have a pointer. You have cat, right? Let's say old cat. And you have your age, you have your weight. Well, there's this pointer. So this is your age and this is your weight. Let's say 5'9", right? So in all your functions, you actually have a pointer that points to this, to your current object. So the reason why you want to return you do star this is because star this means, okay, I'm going to return the data that this is pointing to, and that's this current object. So they do, if this is equal to RSHS, they return star this. So if this memory address is the same memory address as RSHS, they return the current object, return this current object. So then it doesn't delete its own memory, okay? Because before it would call the destructor, right? And then what it would do is it would delete its own memory if you don't handle the case of cat2 is equal to cat2. So after a while, cat2 is assigned to the value. Two issues here. What happens if cat2 is age is a pointer and it points to happens to point to the original values of cat2? And the thing is the same thing as a shallow copy. So what we did was we changed it to a deep copy. But what happens if you assign cat to itself? No one likes to do it on purpose. It's possible to do this by accident when references and dereference pointers hide the fact that the assignment is to itself. So if you did not handle this problem carefully, cat2 would delete its memory allocation. Then when it is ready to copy its values from memory to the right-hand side, there would be no memory. So to protect this, your operator must check to see if the right-hand side of the assignment operator is to the object itself, and it does this by examining the value of this pointer. So it does that. We did that. So now when you run it, here, let me just delete this. When you run it, you get, oh, whoops. Okay, here, I'll just run this now. When you run it, you get age is 5, then you set age to 6. And then when you copy the thing, Whiskey's age, it would have the value of 6. Like, it's not going to delete itself. Or it's not going to, well, this just copies the value there. But it's not going to delete itself, and it's not going to have any problems. So this brings us to whether it leaves out the copy constructor and destructor save room. The assignment. If they are the same, then there's no need to do anything because the object on the left side is equal to the object on the right, and it returns the current object. If the object on the right-hand side is not the same, then the members are copied on lines and before returning. You could see the use of the assignment operator in the main program when the cat object called Frisky is assigned to the cat object Whiskers. The rest of this should be familiar. So of course you could also handle the equal operator for overloading, equal operator for equality. And we're going to handle data type conversion. So another thing you've seen how to assign an object to another object of the same type. Consider another situation. What happens when you try to assign a variable of a built-in type integer to an object of a defined class? Wow, okay. So what would happen? Well, you get a compile error. Because you just can't do that. You can't set integer, your counter object to equal to an integer. This is a compile error. So if you want to convert it, you gotta create a if you want to convert it, You could create a conversion operator, a constructor that takes an integer and produces a counter object. So you could do that like what we did before right here. So then given this, the compiler is able to tell the constructor that takes an int as argument. So you could create a constructor that takes a value, right, an int. So then now after when you do counter, create your counter object, you could actually set it to an integer. Okay, you could do that because it automatically invokes a counter the constructor. It invokes the counter constructor where you passed in the value integer of 5, and this will work. So how does it do this? You create a counter called the CTR. This is like saying int x equal to 5, which creates a variable x and initializes it with the value 5. In this case, the counter object is created and initialized with the value int. But the int is an integer, not a counter. So first you must convert it to a counter. The compiler will try to make certain conversions for you automatically, but you have to teach it how. You teach it by creating a constructor. In this case, you need a constructor for counter that takes an integer as its parameter. So that's what they did. And it just automatically knows it. This constructor creates a counter object from integers, and it does this by creating a temporary object in an unnamed counter. For illustration purposes, suppose that the temporary counter object created from the integer was an int. So it actually assigns int to the counter, which is equivalent to the counter is equal to int. So in this step, wasn't a temporary counter created when you ran the constructor is substituted for what was on the right side of the counter. So this is now allowed the compiler to create a temporary counter for you, and if you initialize it, it initializes it to the temporary object. To further understand this, you must first understand that all operator overloading works the same way. You declare an operator using the keyword operator with binary operators, and the right side becomes a parameter. And this is done by the constructor. Thus, a equals to b becomes a.operator is equal to b. What happens when you try to reverse the assignment? Again, this generates a compile error, but the compiler knows how to fix this by creating counter out of an int. Although the compiler knows how to create a counter out of an int, it does not know how to reverse the process. So if you do counter and you initialize the object with a 5, and you try to create an integer object, an integer variable, and you set it equal to the counter object, it won't know how to do that. It generates a compile error. Although before it did know how to set a integer variable to a counter object, and a counter object to an integer variable, because it called the constructor. The constructor passed in the variable 5. That's why this was able to do it. But now you can't really do that. It doesn't know the opposite way. To solve the conversion back, C++ provides conversion operators. These conversion operators can be added to your class. This enables you to specify how to do implicit operator conversions to built-in types. Listing this one note, however, conversion operators do not specify a return value. So you could have a conversion operator, unsigned int. Holy crap. Okay, yeah. I'm actually going to copy this code and then show you guys what happened. So guys, remember how before you couldn't create like an integer, set an integer to equal to a counter object, your whatever object you created. Well, now you can, because you could overload the casting an unsigned int, whatever you want to. Oh, you could overload the conversion operator. So then now you could convert your object to an integer. So now your object CTR counter can be converted to the integer. To do this, we just did operator unsigned int and then these parentheses. Then you just return, you cast it into an int. So that allows you to set an integer variable to your counter object. The compiler knows how to turn counter objects and vice versa. They can be assigned one to another freely. You assign and return other data types in the exact same manner. Wow, so that was all about operator overloading, conversion overloading, and just everything. Just data type conversions, everything. So anyway, rate, comment, subscribe. I'll check you guys later. Peace.